Hi class, welcome to exercise 7D, where we're going to be sketching parabolas by completing the square. In this lesson, your examples and pre-learning will be example 9, finding key features of quadratics in the turning point form. And your pre-learning for this example is questions 1, 2, 3 and 4 in the new book and questions 3, 4, 5 in the old book. And then we have example 10, sketching by completing the square. And your pre-learning for this example will be 7 and 8 in the new book and 8 and 9 in the old book. So it really shouldn't be any surprise to you that this lesson relies upon knowing how to complete the square. So make sure you revise the lesson on this topic if you really need to. Because as we go through this lesson, I'll be assuming that you already understand it. All right, I'm going to see you in the introduction. After our last lesson, we can now find x-intercepts for a quadratic graph such as y equals a times x squared plus bx plus c, just by factoring with grouping. But recall from earlier lessons that not all quadratics can be factored by grouping, but we can complete the square for all quadratics. So, for example, 2x squared plus 4x minus 3 can't be factored by grouping. And I invite you to try that, by the way. But I can turn it into 2 times x plus 1 all squared minus 5. And this is just by completing the square. Now I'm going to ask you a question. What do you think that looks like? Well, it turns out that completing the square will allow you to express any quadratic in the turning point form. Y is going to equal a times x minus h all squared plus k. So as y equals 2x squared plus 4x minus 3 becomes y is equal to 2 times x plus 1 all squared minus 5, and that's just doing what we did above. Therefore, a is equal to 2, h is equal to minus 1, and k is equal to minus 5 as the constants in that turning point form. And from what we've already learnt about the turning point form, we know that the turning point is going to be minus 1, minus 5, because as we learnt, we could rewrite the rule for that parabola as y is equal to 2 times x minus 1 all squared minus 5. And that's because a minus is a plus, and we need to have it in the form with the minus to know what our h value is, which of course is the x value in our turning point, and k is the y value in the turning point. And then to find the y-intercept, we're just going to sub in 0 for the x, and 0 plus 1 is just 1, so 2 times 1 squared minus 5 equals minus 3. So that was how we did it with the turning point, but it is worth noting that the y-intercept is equal to c for y equals ax squared plus bx plus c, as we saw when we were factoring with grouping. So perhaps you don't have to work it out the long way as we did with the turning point, because you've got both those bits of information there. Anyhow, as always, the x-intercepts is where y equals 0. So in relation to our example equation, that means that 2 times x plus 1 all squared minus 5 equals 0. So then when I add 5 to both sides, I get my next step. And while we're solving for x, we're going to divide both sides by 2. And then to get rid of that square, we need to take a square root. But don't forget that it's a plus and minus square root. Okay, because a minus times a minus is also a plus. And finally, we just need to minus 1 from both sides. So we're left with x is equal to minus 1 plus or minus the square root of 5 over 2. Okay, so we found all the major points. So let's draw some axes. And I know I need to go all the way down to 5 here. And I'll add some axes for the x-axis as well. So let's mark in the turning point where x has minus 1 and y is minus 5. And the y-intercept will be where y is minus 3. And it's worth giving you a pro tip now that I'm going to write in the exact values for the answer, but I'm going to use a calculator to estimate whereabouts on the number line that square root is. So let's have a look at minus 1 minus the square root of 5 on 2. So OneNote will let me evaluate that. And we can see it's around about minus 2.6. And of course, I'm going to cheekily write in that I know that that is minus 1 minus 5 on 2 rooted. And then the next step is to find out what it is with the plus. So it's around about 0.6. And cheekily, we're going to write in the exact result. So sorry about the squiggly writing, but you know what value should be there. So now I can draw in the parabola y is equal to 2 times x plus 1 all squared minus 5. And we also know that another way of expressing that is y is equal to 2 times x squared plus 4x minus 3. So in one way this is a new lesson, but we're really just combining two things you've already learned here. I've completed the square, which we did in our quadratics block, and I've used the turning point form, which we've already done in this part of the unit. And if you remember in the quadratics part, we were talking about numbers of solutions. Well, we're going to have to now consider the amount of intercepts. So for y is equal to a times x minus h all squared plus k, i.e. a parabola in the turning point form, if k in that formula is 0, then we have a perfect square. So an example would be y is equal to a times x minus h squared. Then we'd get a parabola that looks something like this, or maybe another one that looks something like this. And so yeah, it's worth noticing that we've got one intercept and the turning point is on the x-axis. And for the turning point form, if a and k are both positive or both negative, then we're not going to have any intercepts. So you'll find that the turning point is a minimum and above the x-axis like this when a and k are both positive. Or it's going to be a maximum below the x-axis, just like this, if a and k are both negative. And if a and k are different signs, and by that I mean one's positive and one's negative, then we're going to have two intercepts. So for example, a is greater than 0 and k is less than 0, then you get a parabola that looks a bit like this one, i.e. one with a turning point that's a minimum that's below the x-axis. And no surprises for guessing that if a is negative or less than 0 and k is greater than 0, then you get a parabola that looks a little bit like this one, where the turning point's a maximum above the x-axis. Alright, so that's pretty much all the new information, and we're going to be working with these techniques in the examples. Because we're starting to stretch ourselves, I would like everybody to pause the video right now and have a go at the building understanding questions in the new book, which translate to questions 1 and 2 in the old book. So hopefully we lay a really good foundation for the rest of this lesson. Alright, I'll see you in the next section. So hopefully you've revised completing the square on your own. But before we get on to completing the square, we're going to revise describing a parabola in the turning point form. So for y equal to a times x minus h squared plus k, we have a quadratic rule that's expressed in the turning point form. And these constants, a, h, and k, tell us all that we need to know about the parabola. So if a is greater than 0, then our turning point is a minimum. And if it's less than 0, our turning point will be a maximum. And our turning point itself will have an x value of h and a y value of k. And as usual, the y-intercept is where x equals 0. So you can just sub in 0 for that x and you'll get y equals a times 0 minus h squared plus k. And just a little bit of algebra will tell you that the y-intercept is a times h squared plus k. But I'm guessing that most of you will just sub in x equals 0 because our equations aren't that complicated normally. And finally, the x-intercepts are where y equals 0. So you're going to have to find the solutions to 0 equals a times x minus h squared plus k. But if you're unsure of how to do that solving, you're going to need to revise our lesson on solving quadratic equations by completing the square. Or you could refresh your memory by watching me complete example 9, where for y is equal to minus 4 times x minus 1 squared plus 16, we're going to do the following as the questions ask. Alright, so part A is asking us to find the turning point and whether it's a maximum or minimum. So I can see straight away by underlining these two values that our turning point is going to have an x value of 1 and a y value of 16. So make sure that you don't get the negative sign mixed up there, okay? So I know it's not the first time we've seen this, so some of you say it's easy, but there's still an opportunity to get confused there. Some of you might think that the x value of our turning point will be -1 there, okay? So we're worried about what we're minusing. That's what makes it the x value, okay? And just let me note here, this is because h is equal to 1 and k is equal to 16. Okay, so don't forget it's x minus h, and we've got a -1 there. All right, and the other half of the question was, is it a max or minimum? Well, as I said before, if a is less than 0, then it's going to be a maximum. So we know that the turning point is a maximum because a is -4. All right, that's pretty straightforward, right? So let's just get straight on to part B now, where we're going to find the y-intercept. And because the y-intercept is where x equals 0, we're just going to sub in 0 for the x. So we end up with y is equal to -4 times 0 minus 1 squared plus 16. And you can see we've got the same equation as above. It's just a 0 for the x. Okay, so we've got -4 times -1 squared plus 16. And -1 squared is 1, so we've got -4 plus 16, which is just equal to 12. So therefore, our y-intercept is 12. Okay, finally in part C, we're going to find the x-intercepts, which is, of course, y is equal to 0. So when we sub in y is equal to 0, we end up with 0 is equal to -4 times x minus 1 squared plus 16. Lucky I could see part B there, right? So if I add the -4 times x minus 1 squared, I've got 4 times x minus 1 squared equals 16. Then I can divide both sides by 4. And because the square root of 4 is equal to plus minus 2, okay, and when we've got simple square roots, it's easy to explain. -2 times -2 is equal to 4. So that's the definition of a square root. All right, so let's take that square root, and if we add 1 to both sides, x is equal to 1 plus or minus 2. So hopefully we all know that that means x is equal to 3 or x is equal to -1. I'm sure 1 plus 2 is fine, and 1 minus 2 as well. All right, let's use OneNote's magic and have a look at what that graph looks like. Okay, luckily it's recognized my writing, so if I select an action, I can graph it, and I'm going to mark the key features in on the graph and insert that on the page. All right, we don't need this anymore. All right, we can see here we've got the turning point of 1 and 16, and we've got a y-intercept here of 12. And the x-intercepts are -1 and 3. Hopefully you can see the scale that one of the grid lines makes up 2 in the x and y direction. Anyhow, I'll leave it there because the question doesn't ask us to graph, so that's a little bonus. Yes, you're welcome. And of course, it's a good skill to learn in the OneNote there. But anyhow, you should pause that video now and do questions 1, 2, 3, and 4 in the new book, or questions 3, 4, and 5 in the old book. And then when you hurry back, we'll actually do some completing the square in the next section. When we complete the square, we're going to automatically put our quadratic into the turning point form. Then we can use the techniques that we've already mastered to find the turning point and intercepts to draw the parabola. Okay, so let's put this into action by jumping straight into example 10. Where we're going to sketch the following graphs and leave x-intercepts in the exact form. And by exact, that means leave the surds as surds. Okay, so in part A, we've got y is equal to x squared plus 6x plus 15. And just as a side note, 6 on 2 is equal to 3, therefore 6 on 2 squared is equal to 9. And we're going to need this in the next step, because if we add and subtract 9 to that quadratic, we haven't changed anything, because adding and subtracting 9 is the same as adding 0. However, x squared plus 6x plus 9 is x plus 3 all squared. So our quadratic becomes y is equal to x plus 3 all squared plus 6, because 9 minus 15 is 6. And of course, this is the turning point form. So we know that our turning point is going to be minus 3, 6. Okay, because plus 3 is minus 3. And the y-intercept is 0 plus 3 all squared plus 6. Just by subbing 0 in for x. And of course, 3 squared is 9 plus 6 equals 15. And in the turning point form, this quadratic has an a equal to 1 and a k equal to 6. Now we could do a lot of algebra to find that we need to take the square root of a negative number, or we could just remember what I said before, because we've got an a greater than 0 and a k greater than 0, which means there's no x-intercepts. So let me plot the points that I've just found on these axes. So we have a turning point at 3 and 6, and the y-intercept at 15. So I can graph this side of the parabola and the other side by symmetry. And once again, apology for my artistic quote-unquote skills, but that is y is equal to x squared plus 6x plus 15, which we could not have graphed without completing the square and converting it into the turning point form. Okay, let's move on to part B, where we have y is equal to x squared minus 3x minus 1. And hopefully you're confident after the refresh in part A that I can just add 3 on 2 all squared and subtract 3 on 2 all squared. And of course that should be minus 3 on 2 squared. So those first three terms end up being x minus 3 on 2 squared. I hope this is ringing a few bells for you. Regards completing the square. Let's clean up that quadratic. So we've got y equals to minus 9 on 4 minus 1, because minus 3 squared is 9 and 2 squared is 4. And now I can make that all y equals x minus 3 on 2 squared minus 13 on 4. Okay, because minus 1 is minus 4 on 4. So once again, we've converted this quadratic into turning point form, and a is equal to 1, h is equal to 3 on 2, and k is equal to minus 13 on 4, which is going to give us a turning point of 3 on 2 and minus 13 on 4. And looking at the original equation, we can see that c from that sort of form is minus 1. So therefore, our y-intercept is just going to be minus 1. So here comes the fun part, where we work out the x-intercepts, which is just where y is equal to 0. Okay, so I've just rearranged that equation and written 0 for y. So of course the next step is adding 13 on 4 to both sides. And then we take the square root of both sides, not forgetting that we have a minus and plus version. And hopefully you recognize that the square root of 4 is 2. And we can now add 3 on 2 to both sides. And that does look a bit nicer if you put them all on the one fraction. So I'm going to rewrite that as 3 plus or minus the square root of 13 on 2. And as you know, I want to use a calculator to know where that is. So one value is 3 on 2 plus root 13 on 2. And that is around about 3.3. And the other one is 3 on 2 minus root 13 on 2. And that is minus 0.3. So we can use these axes and mark in the turning point at 3 on 2 minus 13 on 4. And the y-intercepts at minus 1. We know the x-intercepts are around about minus 0.3 and 3.3. And I'm going to first draw the parabola. God, that's bad. But anyhow, we're going to mark in the exact values for the x-intercepts. So let me do that now. And just as another reminder about the importance of the axis of symmetry and where the x-intercepts lie, you should see that we have a bit less than 2 when we move from the axis of symmetry to the x-intercepts. Okay, so we would not have been able to graph this by grouping. This is another example where completing the square becomes necessary to graph the quadratic. All right, and don't forget the pro tip that I gave earlier, that where I've written the x-intercepts in exact form, I've used a calculator to get a good idea of where they should be. Okay, so we've really hit the point of the major skill you're trying to learn today. So right about now, you should pause that video and work on 7 and 8 in the new book and questions 8 and 9 in the old book. And then you can come back so we can summarize that lesson. Okay, in this lesson, we've seen that completing the square automatically puts a quadratic into the turning point form. But don't forget that sometimes factoring by grouping is still easier. So in a typical situation, unless a question asks for a particular method, you can choose what works for you. All right, so in this lesson, a successful student will know that completing the square can be used to express any quadratic in turning point form. Be able to find any x-intercepts from the turning point form of a quadratic. And finally, be able to sketch a quadratic equation in turning point form, labeling all the key features. All right, so make sure you take some good notes there, lots of practice, and hopefully you can see it all coming together as we approach the end of the unit. I'll see you in the next video or in class. Bye.